Inelastic demand. One good way to remember perfect inelasticity is a capital I is perfectly vertical, as is the perfectly inelastic curve. Okay? So inelastic is vertical, perfectly inelastic. In this scenario, there is zero price sensitivity. Consumers don't care what you do to the price. This is the quantity they want, period. Okay?
What was an example of a product like that?
Insulin is probably one of the best examples of a product for which there would be perfectly inelastic demand. Another one would be if a child couldn't take breast milk and had to have a specific kind of formula. There are kids who develop allergies to some of the things that are in baby formulas, and they'll go through 7 or 8 different kinds, and then there's one that the baby can take. Their demand for that formula would be perfectly inelastic, because the other option is let your baby die. So those kinds of situations where it's a life or death thing are about the only time you're ever going to see perfect inelasticity. It's not a very common phenomenon. Okay. So when price falls by 10%, if there was any elasticity, you would expect the quantity demanded to fall. It does not. And so you have a zero elasticity if you work out the actual math. Okay? So perfectly inelastic demand equals zero elasticity. Seems like common sense, because it is. Started you off easy. It gets harder from here. I want to begin with the review. We were on the downhill slide on Friday. Okay, inelastic demand is when there is some slope. It's relatively steep. Okay, it's not a perfect one-to-one slope. Price sensitivity is relatively low. People aren't going to change a whole bunch. For instance, when you get to college, textbooks, you're going to have a relatively inelastic demand for textbooks. There's a certain point at which you wouldn't buy a book and you'd just borrow a friend's or photocopy pages out of someone else's book. But for the most part, you're going to want your own books, especially for classes in your majors. Another one, this is the graph for gasoline in the short run, where we talked about this earlier, that people have a hard time adjusting to changes in price of gasoline overnight, even within the same week or a couple of weeks. It's just hard to change your lifestyle that rapidly. And so your demand for gasoline is relatively inelastic. Okay? So if we actually do the math on this one, we bring price down by 10%. You would think we should have a whole huge increase since price is that much cheaper. But quantity demanded goes up by less than 10%. Look at gasoline this way. We tend to think about gas in terms of increases in price, but when gas prices go down, do you just all of a sudden go out and go crazy and start cruising and driving all over the place for the heck of it? No. Again, that's a huge lifestyle change that you just don't make overnight. And so your demand for that doesn't change a tremendous amount. If all of a sudden one of your college textbooks goes on sale and it's $25 off, oh wow, you're going to go out and buy another one? Probably not. Okay. So what's our actual elasticity up here if we do the math? Less than 1. So for demand to be inelastic, the price elasticity of demand is less than 1. That's the mathematical test for it. Price elasticity of demand is less than 1, and demand is inelastic. Yes, Zach?
Why do you have a less than on there?
Because we don't have actual numbers here, and so if you've got a less than 10% change in quantity over a 10% change in price, then your answer is going to be something less than 1. Okay? Are you going to have to memorize these price elasticity of demand figures? Yes, you are. Fair warning, you've been told. Start now. Flashcards, maybe. Then there's unit elastic demand. Okay, this one's got an intermediate slope. It's a pretty close to 1-to-1 ratio. In fact, it's darn close to 1-to-1. If we decrease price by 10%, quantity demanded goes up by 10%. And so our price elasticity of demand is going to be 1. An additional tidbit for those of you who may go on to business: when you have unit elastic demand, and only when you have unit elastic demand, price changes result in 0 change in revenue. Okay? This is also something that you may hear on the AP exam. They'll ask, they'll give you a price elasticity demand number, and they'll say, will the business's revenue increase, decrease, or remain the same if they do X to price? The only time you'll ever say remain the same is when the unit elasticity of demand is 1. Okay? It matters not whether they increase or decrease price, because quantity demanded will move in synchronicity with that change. Am I going too fast? Okay. Elastic demand. Now we've got a flatter demand curve. Your price sensitivity is relatively high. If price changes a little bit, you react a lot. So price falls by 10%, quantity demanded goes up by more than 10%. Woohoo, it's a sale, let's buy 3 times as many. Yay. Anybody want to guess at what the price elasticity of demand is up here? Greater than 1. Well, because you can be given actual numbers and apply the equation and figure out without having to graph it or guess. These are actual concrete things you can do in economics, and since there aren't that many of them, treasure this. You can know whether you're right or wrong with elasticity questions. But only if you've done the memorization. Will you have to know the actual name and its number? Yes. Well, but I explain it. No. I don't care how well you explain it, you have to know the economic term. Okay. Ready for the last one? What do you suppose it's called? Without looking at your printed out notes.
Perfectly elastic demand.
Perfectly elastic demand. It's the opposite of perfect inelasticity. So what does it look like? Absolutely horizontal. It's the opposite end of elasticity. This is where it doesn't matter what quantity people want, they'll only pay one price.
What?
Does this make any sense? Yeah. The tiniest price increase here is going to cause quantity to do what? 0. You change price 1 eensy bit, and I'm not buying any. I don't care. Even if it's lower, I don't care. I want to pay $1 for that. I don't care if you're only going to charge 10 cents. I'm not buying it. I hate change in my pocket. Okay. I actually love change in my pocket, but anyway. All right.
So what would...
Okay. This is tough. Let me give you the actual math here. Infinity! Price elasticity of demand is infinity with perfectly elastic demand. Okay. You are a wheat farmer. Okay. Small family farm in Iowa. Okay. We're going to use Iowa as our example here. You grow wheat. The demand curve for wheat is downward sloping. The price right now, the market price for wheat is about $5 a bushel. Okay. If you charge a price of $5, you can sell as much wheat or as little wheat as you want. Can we agree on that? Okay. If you charge $5.05 a bushel, how much are you going to sell? None. None. Why would anybody buy wheat from you at $5.05 when they can go anywhere else and buy it at the market price of $5 a bushel? Right? Okay. Now, what happens if you drop your price to $4.99 a bushel? It's not about losing money. We're not talking profit. What happens to demand for your wheat?
It's just the same. I don't know.
Everybody wants to buy their wheat from you because they can save a penny. Can you meet that demand? No, you have a small family farm. So, what?
So basically this isn't uncommon.
No, this
The fact
this-
that you can't think of a like you can, but like
this doesn't happen, but it does happen because this wheat farmer thing is right. If I could get, it's also a common sense thing. If I'm that small family farmer, okay, and you could get $5 a bushel, you have no problem getting $5 a bushel. Why would you sell it for anything less than $5 a bushel? Right? That would be stupid. It would be completely irrational. Completely irrational. You're having no trouble selling it at $5 a bushel. Don't sell for less than that. Are you going to sell any at $5.01? No, because all they have to do is go to the grain elevator across the street and buy wheat at $5 a bushel. Okay? So, perfectly elastic demand happens when there is adequate supply and a well-established market price in a market. And that perfectly elastic demand lands at that market price.
But I feel like there's shortages. It's not like there's an endless supply.
There is not an endless supply. However, there's also not an endless demand.
So you're saying they're growing perfectly?
No, not necessarily. But it's not a global market. I'm talking about wheat supply and demand in this small market in Iowa. I'm not talking about the global trade in wheat. Okay? This is the demand curve that faces an individual producer of wheat in Iowa. Okay? When there are a lot of close substitutes available, what happens to demand? When there are a lot of close substitutes available, what happens to demand? It's more elastic. Whoever said that, good job. Demand is more elastic when there are a lot of close substitutes. Are there a lot of close substitutes for a bushel of wheat? No. A bushel of wheat is a bushel of wheat. A bushel of rye is not a bushel of wheat. Okay? So, the thing is, don't think about different products. Think about my bushel of wheat and Adam's bushel of wheat and Laura's bushel of wheat and Connor's bushel of wheat and Treston's bushel of wheat and Maddie's bushel of wheat. We have 6 bushels of wheat lined up. Which one do you buy?
Well, it's $5.
They're all $5.
So then you just grab one.
Then you just grab one because a bushel of wheat is a bushel of wheat. And they're all perfect substitutes for one another. And when there are close substitutes available, what happens to demand? It becomes more elastic to the point where we have
Perfect.
1 million bushels of wheat, which are all perfect substitutes for one another.
But why wouldn't they like? Why would one of the people look at the other person and go 5 cents lower? So you automatically look.
Because my likelihood of selling it
There's only one customer though.
at that instant in time, there's theoretically an infinite number of customers. The minute you go below that market price, then yes, you are creating a shortage. But at the market price of $5 a bushel, there's no shortage. It's the market clearing price. That's how that $5 was established. It's where supply meets demand. There's no incentive for you to go lower because you're not going to have any problem selling all you want to sell at $5.
I feel like you can only like sell more though.
You only have so much to sell, and the market clears at $5.
I feel like it's like really like specific. Like someone's not gonna sell all their stuff, and that person that doesn't sell all their stuff.
What's the definition of market clearing?
I get it.
Quantity supplied equals quantity demanded.
Yeah.
It's theory, Kyle.
Yeah.
It's theory. Okay. Yes, there's always something left on the shelf. But why is it left on the shelf?
Because it's more too high.
Because the price wasn't low enough. If the price was already at the market clearing price, would it be left on the shelf? No. Okay? Are you past? Okay. All right. Okay. So you've been asking for examples. You've been saying, what's this look like in the real world? Here you go. Elasticities in the real world. Anybody surprised that the demand for Mountain Dew is relatively elastic? No. What term would we use to describe eggs in terms of elasticity? Which one of our 5 terms? It would be inelastic. What about housing? Still inelastic. Beef? Restaurant meals? Mountain Dew? Okay. But you've only used inelastic and elastic. Aren't there 5 terms? So, so we didn't have any that were 0, and we didn't have any that were infinite, and we didn't have any exactly at 1. Okay, good. I want to make sure I couldn't, what? No, I just wanted to make sure I couldn't cow you guys into saying something wrong. Okay. So we have a straight line demand curve. Okay. Now, although we use straight lines over and over and over in our examples, guys, what's the one thing we know? They don't actually exist in nature. Nature abhors a straight line. Okay. Nature abhors a straight line. Hates, detests. Okay. Read this and think for a second. Just because the curve is a straight line does not mean that its elasticity is constant. Those of you who math have probably already figured out why. Aaron, you're massaging your temples. Are you there? Can you tell us why? You can't? Okay. Let's do the math. Elasticity between $30 and $20 is 5. We would say that's pretty elastic, wouldn't we? That's elastic. Okay. Between $20 and $10, we have a $10 change in price and a 20 unit change in quantity, but it's about percent change, right? What do we have here?
It's the elastic. Oh, I know.
Unit elasticity.
Yeah, I don't understand where like the 200 came from. Sorry. I don't know.
Like, why is it 200% over 40%?
I knew the answer to that before you asked the question. Oh yeah, midpoint.
20 over 10 is 2 times 100% is 200%.
So 0 to 30. Right, the midpoint method.
How we're going 20 to 30?
Well, let's do the first one. So from the point 0, 30, okay? Quantity is 0 at the price 30 to the point quantity 20, $20. The rise is negative $10, right? And the run is positive 20. So the slope is negative 0.5. What? And we turn the slope into elasticity, absolute value. I'm not, okay.
Are we gonna have to like find percentages?
Can you write it on the board
Yeah, can you like write it on the board?
for us visual people?
Well, I get this. Are we trying to figure out
It's-
how to get the elasticity, like the first one? Is that what we're talking about?
Yes.
I get that.
Well, yeah, it's the midpoint formula.
The end value minus the first value.
Yeah. All right, so I'll set that down. And
Sorry.
so it's the end value, so we went from 30 to 20, minus the start value, over the midpoint, which is,
25.
okay, and that is, which is 1 over 2.5. Is that right? Okay, and then our end value minus our start value over the midpoint. And then the math happens. How do I math
You
that?
can multiply it by
Huh?
1 over 2.5 times 1/2.
Yeah.
It's the same thing as dividing by 2.
Yes?
Right.
Okay, I'm confused as why you use 20 minus 0.
The two
where
is
you
the,
end up
the two is supposed to
minus the start point.
be the 2 is supposed to be the numerator, and then the 1 over 2.5 is supposed to be the denominator.
Oh yeah, quantity over price,
Yeah.
right?
Yep.
Okay, so it should be 2 over 1
Yeah.
over 2.5.
And then so it'd just be 2
So that's-
times 2.5.
Yeah, 2 times 2.5.
Yay.
5.
Nice job, Adam.
Can
Adam.
you explain
Can I
the 20
explain?
minus 0 again, please?
Okay. The midpoint formula. I think we did this last Thursday. It's the end quantity minus the start quantity over the midpoint quantity over
Yeah,
the
20
end
divided by 2
price
is 2
minus
times
the
100%
start
is just 200%.
price over the midpoint
End value is 100.
price.
Start value is 30 is negative 10 over 5.
Yeah, this is the midpoint formula. I told you last Thursday. I know we
We
did
got
this
1 over
Thursday.
like 2.5.
This is how you calculate it.
That's bad, but like the thing we did is we just
Was that 40%?
no, the thing we did is we just did 2 over 1 over 2 times 5 or like 2 times yeah, exactly. Because 1 over 2.5
Is
the
it
same
like a
thing as
derivative?
40%.
It's a derivative.
Someone who maths, I don't,
Never mind.
I hear not really, no.
That's like,
It's just like your standard math midpoint formula, except they added fancy words to it.
Yeah. I hate fancy words.
X and
we just
Y.
not
I
math.
mean, I don't math, but I don't have a huge amount of difficulty applying this formula. It's just plug and chug.
It's the words that are going out.
It's what?
It's the words.
It's the words? Okay, so come with that math formula up here for the
Some
math.
math for us.
What are we? What is he
Here's,
doing?
here's the math formula for the same thing,
Are we doing slope or?
apparently.
So really it'd be Q2 minus Q1 over.
Except that it's not, because you have to divide by you have to divide the y2 minus y1 over the midpoint of the graph. It's not the same thing.
doesn't do this and fall off a cliff.
Wait, why what?
Why a demand curve doesn't do this.
So
they really go like that.
Yes,
Yes,
they really swoop.
that would make it just a constant elastic.
They really get closer to perfect elasticity the lower the price gets. And they get closer to perfect inelasticity the higher the price gets. If you think about it common sense wise, that totally makes sense.
And then you put economic words with it, and it doesn't.
And then, yes, then I add economic terminology and it all falls apart in your heads. I understand.
It's like
Yes.
I thought
An actual demand curve is going to be like a very flat letter C.
wouldn't that mean elasticity increases as you went down because it's more elastic down here? Am I confusing myself?
You're confusing yourself.
Wait, yeah, no, I think he's right. Because inelastic.
Yeah, Adam is right.
Yeah, because inelastic is less than 1.
Why am I confusing myself?
confusing me too.
Elasticity falls.
Okay, I got it. It's like
Elasticity falls. Because it's not all about slope.
no, it's just like inelastic down here is more like an I, and that'd be less than 1.
But you're drawing the curve wrong. Curves don't bow. That's a PPF that you've drawn bowed out. A demand curve arcs inward. Let's move forward and actually apply this in some real situations.
So was that last thing you told me was correct still?
That it decreases as it moves down and to the right? Yes. Okay. Considering the scenario, which is our wheat farming, okay? If you raise your price from 200 to 250, does your revenue go up or go down? When doesn't revenue change? Only when it's unit elastic. How do we know if it's elastic or not? You need to know its elasticity. Let's work through it. Here's an equation you have to know. It's a pretty common sense equation, is it not? Revenue equals what? How much money I get. Price times quantity. A price increase will do two things to revenue. A higher P means you're making more money each unit you sell, but a higher P also means a lower Q, which means you're going to sell fewer. Right? Curse that law of demand. The question is, which one has more impact? And so you have to apply price elasticity of demand to answer your original question, do I raise my price or not? Michael?
So did you say that revenue only rises if it's unit elastic?
No. If you have unit elasticity, revenue does not change. I think this is all going to crystallize here for you in a second.
You say revenue does not change?
At unit elastic. Okay. If demand is elastic, can you predict? What's price elasticity of demand if demand is elastic? More than 1. And so that means that quantity is going to change by more than 1 for every unit change in price. So if demand is elastic, what's going to happen to revenue if we raise the price? Does that make sense? Should be common sense. The question is being able to determine your elasticity. If you don't know what your elasticity is, you're just guessing if you just go out and start changing price. So the fall in revenue from a lower Q is higher than the increase in revenue in a higher P when you have elastic demand. Well, think about the determinants of elasticity. When is demand elastic? When there's a lot of substitutes. So if you go changing your price, I'm going to go buy in something else.
I'll be fine if when I have the visual graph, I can just,
Okay.
it's just the words. The
Well, you'll have word problems about this too.
Then I'll just draw a picture with
Okay. If you have jeans and the price of Levi's goes up,
just buy some.
buy some Lees, buy some,
Lucky.
yeah, buy 8,000 other brands of jeans, right? Buy some of those sweatpant jeans.
No.
I saw an article in the paper about joggers and men's, and it's the hottest area in men's bottoms this fall. All men are going to be wearing sweatpants now, and they're going to have the elastic at the bottom again.
My brother wears Swartz.
Swartz?
Yeah, he cuts his sweatpants so they're like capris
I
short.
respect that.
No.
That sounds like the male version of yoga pants.
Yeah, it's just not okay.
Ew.
I might invest in that.
All right. So Tony requested a graph.
Yes.
A graph. All right. Remember our websites, and our initial question is, do we raise our price per website from 200 to 250? Well, our elasticity is 1.8. Should we raise our price that much?
Probably not.
We're going to work harder and make less. Oh, wait, no, we're not going to work harder. We're going to work a third less and make less.
You might try now or
We'll start here.
But if you lower the price